This is going to be just a quick video on how we know, or some different ways to check if a regression equation fits a data set, and maybe kind of a cautionary thing. So what you see here are three data sets, and for each one of those data sets I entered them into my calculator and I did linear regression on it. And what I want you to see here is that the lines are extremely similar, right? If you were going to really go to like you've got like 3 plus 0.5x, here we've got 3 plus 0.5x, and here we've got 3 plus 0.5x. The correlation is 0.82, 0.82, and 0.82. And of course, our squareds would be very similar, 0.67 as well. So for every one of these three equations, we have a regression equation that is almost the same. We have a correlation that's almost the same, and an R-squared that's almost the same. So not only do they have the same line, but the line seems to fit each set of data about the same. Okay? Now, on the next slide, I'm going to show you what the graphs look like. Okay? So on this first equation, you'll see I graphed the equation and the points, and the line fits very, very well. This is what you would say the regression equation should look like. And if you pulled out the residual plot, there's the residual plot, that's what a residual plot should look like as well. It's got no pattern, it's just scattered points in relation to the axis. The next equation, or the next data set, you'll see that the line fits the data pretty well, but at the same time, it seems to be getting worse. And if I pull in my residual plot, there it is. So a residual plot, remember, shouldn't show any trends. Well, I definitely see a trend here. So what that tells me is that I must be able to come up with a better type of equation. It's not linear, it's maybe exponential, logarithmic. I got to be able to come up with something else. And finally, this last data set, talk about an influential point. Look, right? You look at this, and all of the values here, all of them have the same x value. Maybe you noticed that before, except the 1. And that one value gives us a correlation that's that good. So when you bring in this residual plot, there it is. So here's why I show you this. You can't just rely sometimes on the numbers. You can't just rely on the correlation and the R-squared, the coefficient of determination. Sometimes you actually should, or I guess all the time, you actually should look at the graph and make sure, is what I did appropriate for this data set? And back yourself up with your residual plot. You know, I would look at this second data set and I'd say, boy, it looks, yeah, it fits, it's got a good correlation, but it doesn't look very good. The residual plot bears out. This trend bears out to me that absolutely we should be looking for something else. So use the correlation, use that coefficient of determination, that R-squared, but don't discount actually looking at the visual and the graphical to decide if an equation or a regression equation works.